Hi everyone, we're starting video 23 on the quadratic formula, which is found on section 9E of your textbook. Okay, so some of us are already quite familiar with the quadratic formula, and what the quadratic formula does is that it allows you to find all the x-intercepts, or it allows us to find the x-intercepts for all types of quadratic equations that we have. We've looked at removing common factors, we've looked at difference of squares, we've looked at perfect squares, sum and product, we've looked at splitting the middle term, and the latest we looked at was completing the square. But the one formula that works to solve all quadratics and find the x-intercepts is always going to be the quadratic formula. So the quadratic formula is written right above here, where it says to us that x is equal to the value of negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, what does that mean? We know that in the quadratic general equation, we know that we have ax squared plus bx plus c. That is our general formula for the quadratic. Now, the value of the a is the number or the coefficient that is in front of the x squared term, so the squared term. The value of the b, or the coefficient, is going to be in front of the x term, and the value of the constant, c, is going to be after the ax squared and the bx. So it'll be just the value of the constant. Now, when we are looking for our values of a, b, and c, to be able to replace them in the given equation here on the left, we have to make sure that our quadratic is written in the proper format, meaning that we are going from highest degree to lowest degree, from ax squared to bx plus c. So they should be placed in the proper order. So, if I were looking at this first question here, solve for x, where I have a being, we have 9x squared equals 6x plus 1, what I would do initially is I would bring everything over to one side of the equation, and I would put them in the correct order. And I would set it equal to 0, so that I would have 9x squared minus 6x minus 1. Now, my value of the a term in front of the x squared is equal to 9. My value of the b is the value of negative 6, which is in front of the x term, and my value of the constant c is equal to negative 1. Now, my only job at this point is that of replacing these values of a, b, and c into the proper position in the actual formula. So here's my formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, and x equals that. That is my x-intercept. So that I will write negative 6 plus or minus, and now we're going to have negative 6 all squared minus 4 times 9 times negative 1. And that will all be divided by 2 times our value of a, which is 9. Now, when I simplify my value of x here, I get 6 plus or minus the square root of, and I'm going to have 36. Now, negative 4 times 9 is negative 36, times negative 1 is positive 36, so that we have 36 plus 36, and that will all be divided by 18. So further simplification will prove for us to have 6 plus or minus the square root of 72, and that will all be divided by 18. Now, we can do one of two things, depending on what the question is asking. We could leave our answer in square root form, or we could put our answer in decimal form. In decimal form, it obviously means that I will do 6 plus or minus the square root of 72 on my calculator, which will be approximately 8 point something, the root of 72, and that'll be divided by 18. So I could do the positive and negative of that and come up with my two decimals. The alternative way to do this would be to break this up so that I have 6 plus or minus. Now, since the root of 72, I'm just going to put this off to the side. Since the square root of 72, the radical of 72 can be broken down into root 36 times root 2. Well, root 72 then is really equal to 6 root 2. So I can rewrite root 72 as 6 root 2, and then I divide that by 18. Now, my final answer would get broken down into, then since I can remove a 6, I would end up with 1 plus or minus 1 root 2, or just root 2, all divided by 18, so that I end up with, now removing the 6 and the 18, so I have 3 in the denominator, and so my final answer would go to 1 plus or minus the root of 2 divided by 3. Now again, keep in mind that there are two answers in this particular case, one of them being 1 plus the square root of 2 all over 3, or the other case being 1 minus the square root of 2 all divided by 3, and that would give me my possible values of x. Okay, so that would be one way of solving these problems. Let's take a second example. A second example now, this isn't quite written out as a quadratic, but we can certainly put it as a quadratic by getting rid of our denominator of x plus 2 here in this fraction. So everything in this entire equation is going to get multiplied by x plus 2. So I will have x multiplied by x plus 2 plus 1 is equal to 4 times x plus 2. Notice that the x plus 2 gets cancelled out here because I no longer need it. My x plus 2 denominator is gone. So that I have x squared plus 2x plus 1 equals 4x plus 8. I now bring everything over to one side of the equation, so I have x squared plus 2x minus 4x plus 1 minus 8. And I set that equal to 0, so that I now have my quadratic x squared minus 2x minus 7 is equal to 0. All right, having been given this, I know that there are no two numbers that multiply together and equal negative 7 and added give me negative 2. I could complete the square, but at this point I'm choosing to use the quadratic formula. So I'm going to say my value of a is equal to 1, my value of b is equal to negative 2, and my value of c is equal to negative 7. And I will replace that inside the formula, which is negative b plus or minus the square root of b squared minus 4ac, and that will all be divided by 2 times the value of a. So it will become negative 2 plus or minus, and this is still x equaling, I'm forgetting to put the x equals, and it's negative 2 plus or minus negative 2 squared minus 4 times 1 times negative 7, and that all gets divided by 2 times 1, so that we end up with 2 plus or minus, and we've got 4 plus 28, all divided by 2, so that we have 2 plus or minus root 32, all divided by 2. I can further simplify this. I'm just going to bring this up here. I can further simplify my root 32 to 2 plus or minus. Now the square root of 32 is really like saying root 16. So root 32 is really like saying root 16 times root 2, which is 4 root 2. So that I can say 4 root 2, all divided by 2, and therefore x is equal to, remove a common factor up at the top, so we have 2 bracket 1 plus or minus 2 root 2, all divided by 2. My 2's on the outside here cancel out, and I get a final answer of x equaling 1 plus or minus 2 root 2. And again, remember that there are two solutions here. It's x is either equal to 1 plus 2 root 2, or x is equal to 1 minus 2 root 2. All right. Now, having done those examples, we need to just go back and reflect a moment on what it is, again, that we're looking for when we find the value of x. We've mentioned this numerous times. What we are looking for is the possible solutions, or x-intercepts. So an example here, we can have either two solutions for quadratics, one solution for a quadratic, or no solution for the quadratics, meaning that we have either, in the first case, two x-intercepts, they cross the x-axis. We have one x-intercept, meaning that it touches the axis only at one point, or the parabola never touches the x-axis. So if we look at the three situations here, and we used, we could just simply use here in all three cases, in some of these cases rather, we could just use, in this case, sum and product. I have x plus 4 times x plus 3 when I factorize that, so I get x equaling -4 and x equaling -3. If I look at the next case, I have x plus 3 all squared is equal to 0. Okay, so that we can see that x plus 3 is equal to 0, therefore x equals -3, so I only have one solution in this case. And then I have a situation such as this, where I've got x squared minus 3x plus 8. Well, if I want to use the quadratic on this, I will say a equals 1, b equals -3, and c equals 8. And I can say -3 plus or minus -3 squared minus 4 times 1 times 8, all divided by 2 times 1. And what ends up happening here when we're figuring out our value of x is that we get 3 plus or minus, and I'm going to get 9 minus 32, all divided by 2. And this gives me a negative under the square root sign. And if I have a square root under the, if I have a negative under the square root sign, I've got 3 plus or minus, so 9 take away 32 gives me 23, I believe. Divide -23 over 2. I have a negative under the square root. I cannot have a negative under a square root, so that tells me that's a no solution. And a no solution, therefore, in this case means that there are no x-intercepts, and that the parabola never crosses the x-axis. All right, moving on to the next part. So on top of using the quadratic to find our values of our possible values of the x-intercepts, we can also sometimes, without having to find out what the actual x-intercepts are, sometimes we are just interested in knowing how many solutions there are. So maybe how many solutions there are, meaning how many x-intercepts there are. So there could be 2, there could be 1, or there could be none. So the part that goes underneath the square root sign, so with the square root sign in the formula, in the given formula -b, let me just rewrite that, in the given formula -b plus or minus b squared minus 4ac all divided by 2a, which is our quadratic formula, we said, the part underneath the square root sign, so the b squared minus 4ac, is called the discriminant. And the discriminant is sufficient for us to know whether we have 2 solutions, 1 solution, or no solution. Now, the discriminant does not tell us what the solutions are, so what the possible x-intercepts are, but it does tell us how many x-intercepts there are or there could be. So, we use this delta sign. The delta sign here that I'm putting in red, it looks like the little triangle. The delta sign indicates to us that it's b squared minus 4ac, our discriminant. And what it basically tells us is this, that if I have b squared minus 4ac, and I have a number that comes out of there that's greater than 0, then that means I have 2 solutions, or 2 x-intercepts. If my value coming out of b squared minus 4ac is actually equal to 0, then that means I have 1 solution, or 1 x-intercept. It touches the x-axis only once. And if my b squared minus 4ac is less than 0, then that means that there are no solutions. Now, if I have this question here, find the number of solutions of the given quadratic, x squared plus 2x minus 4, understand that I am not looking for what the x-intercepts are. I am just asking you how many solutions there are. So all I'm asking you to do is take a is equal to 1, b is equal to 2, and c is equal to negative 4. And from there, I'll just take my discriminant, b squared minus 4ac, and I'll say 2 squared minus 4 times 1 times negative 4. Now, when I add that all up together, I do the proper calculations, I end up getting 4 plus negative 4 times negative 4 is 16, and that equals 20. Now, since b squared minus 4ac is greater than 0, well, we know it's greater than 0 because 20 is greater than 0, then we can say, therefore, there are 2 solutions, or 2 x-intercepts. All right, let's just do another example. We'll do a couple of examples here, and one of the examples basically says, now these questions are a little bit more challenging, and what the questions basically are, I took C and I took F. Now if I take question C, I've got kx squared plus 6x minus 3 equals 0, and it tells us that it has 2 roots. 2 real roots means it has 2 solutions, or 2 x-intercepts. So what it wants to know is, what do the values of k have to be in this problem in order for this to have 2 solutions to it? So what I do is I say, well, a is equal to k, b is equal to 6, and c is equal to negative 3. So if I place b squared minus 4ac, and I know it must be greater than 0, then I say 6 squared minus 4 times a, which is k, times my c, which is equal to negative 3, is greater than 0. 36 plus 12k is greater than 0. 12k is greater than negative 36, and now I'm going to divide both sides by 12, so that I get k must be greater than negative 36 divided by 12, which is equal to negative 3. So what does this tell me? It tells me that in order for this problem to have 2 roots, the value of k, therefore k, must be greater than negative 3. All right, I'm going to stop right there. Thank you, and I'll see you next time.